Hello everyone. Hi Ram, hi Tharif. कैसे हो? How was the exam? हो गए exams? Are you over with your exams?
Yes, sir.
Okay. And how much did you score?
I didn't get the result yet.
Same, sir. Didn't get the result.
Okay. And Mamuddin, hello.
Yes, hello, sir.
From where do you belong?
I belong from Hyderabad, sir.
Okay, Hyderabad. And are you also preparing for some competitive exam like JEE or something?
Yes, sir. But I'm not sure if I'll give or not, but I'm preparing for it.
Okay. Hello, Ram. Am I audible?
Yes, sir.
How was the exam?
Okay, sir.
So, and what about your 12th classes? Like, have the classes started for everyone?
Sir, for me, they were teaching the left out 11th practices.
Okay. And what about you guys?
My 12 started, sir.
Okay. What are you? What are you studying in maths?
Relations and functions.
Okay. And what about you, Iram?
Same.
Okay. Cool. Okay. So, guys, it's the first class for 12th. So let us first understand what's the syllabus for 12th class and how are we going to prepare for it. So your major part of 12th consists this calculus. So we have already talked about these terms. So Iram and Tharif are my old student. They have studied here in class 11th as well. So we have, guys, like how do we go to our syllabus. So first we'll understand what are the topics or what are the units, and then we'll take one unit at a time and we'll complete it. We'll try to complete that. So just a minute. Yeah, so first we'll try to understand what's in the syllabus. So first of all, we will be dealing mostly with the calculus in class 12th. So calculus will consist two parts. First is differential calculus, which will be basically based on differentiation. We have already studied about differentiation. So there are 3 chapters in differential calculus. And the chapters are differentiability and continuity and differentiability, which will be based on your limits as well as differentiation. So the chapter that you studied as limits and derivatives in class 11, this will be the further part of that extended part of that chapter only, which is continuity and differentiability. Then there will be, I mean, there are 2 chapters only, but I'm dividing them into 3 chapters because one topic is actually you need to apply more questions for that topic, and that is why I always teach that topic separately as a chapter only. So this is application of derivatives. We will try to understand how can we apply, or what are the uses of practical uses of differentiation, right? So the chapter is application of derivatives. In which you will understand how are you applying your, differentiation in your daily life. Like, where are you applying? So there are so many areas where maths is paramount to actually every area. So, without maths, I don't think there will be formulation for most of the things in this world. So you have to apply differentiation at a lot of places. So you'll understand how to apply differentiation. And then there is one topic which tells you maximum and minimum of a function. So this is also application of derivatives, but application of derivatives, like that. And then this maximum and minimum will be studied separately. And the second part is integral calculus. This will consist 3 topics. First is integration. So this will be based on integration only. All of these 3 chapters will be based on integration. Second will be area bounded by curves. Area bounded by curves. And third would be differential equation. Differential equations. So there will be in total 5 chapters based on calculus, and it will consist of 50% syllabus. So 50 marks exam will be based on this only. If there's an exam of 100 marks. And then there is this topic algebra. Unit is algebra. Scoring topics, there are 2 chapters, matrices and determinants. So you'll start with this only. We'll start with algebra because there are only 2 chapters in algebra, matrices and determinant, and very easy scoring area. So this will consist around 12 marks, 10 to 12% of your syllabus. Then from trigonometry, you have studied trigonometry in class 11. So there will be one chapter, extended version of trigonometry only, which will be inverse trigonometric functions. Inverse trigonometric functions. ITF, also known as ITF. Very small chapter, only 3-4 marks. And then we will have vectors and 3D. Again, scoring from the portion coordinate geometry. So this was from trigonometry. The unit was trigonometry for this. And for this, the unit is coordinate geometry. And the chapter is vectors and 3D. There are 2 chapters. One is vector, second is 3D geometry. And again, scoring unit, no problem. Then probability is constant. And you'll have to study probability if you're studying maths for a long time. So probability again, the extended version of class 11th only, nothing. No, sorry. Probability is something totally different actually. So here for the first time, you're about to study the advanced probability, like advanced method to calculate probability and how to apply probability in real life. Like in most of the cases, you'll understand there are so many phenomena which we are using, in daily life of the probability. So I've already told you guys that I'm studying probability only. So stats and probability. So probability has a lot of use in our life. And the last chapter would be this. This is again a small, very small chapter. So what is this? Just a yes, the chapter is linear programming actually. So very small chapter. There will be one question based on this. Nothing fancy, very easy actually. So you have studied linear inequalities. You just have to draw some graph for linear inequalities in this chapter, and very easily you cover this. So the difficult part for 12th class is this calculus. All the other portion is quite easy to score, and we'll try to understand calculus, and also we have to practice a lot of questions to understand calculus better, right? And I hope you guys are charged up because you're in class 12 now. So it's a basically we are taught to work hard in boards. Have you done this? I mean, can I remove this? If you haven't, you just have to raise your hand if you haven't done. If you're writing, then you just have to raise your hand. Nothing else. And if you're not, then I understand. So this is our syllabus, and now we'll start with the chapter matrices today. So these are two chapters, matrices and determinant. Which belong to actually algebra, and algebra was easy to score as we have understood in class 11th as well. So matrices is, so it's a very basic phenomena, but very useful phenomena. Okay, so this is known as linear algebra, right? So what, and in general, the perception of linear algebra is such that it is easy to understand, and it has a vast use. So let me give you an example of matrices. So you use Excel sheet, right? I mean, we all use Excel sheets in our day-to-day life jobs. So there's if you have a lot of data, right? So to use that data or to extract information from that data, we'll use some tools, or rather we'll use Excel sheet, right? And we can easily find out the sum, and there are so many things which we can do if we are using Excel sheet, right? So when we store a lot of data, these are the things that we can use, and all of these statistical tools are based on matrices, because matrices is that phenomena which is the representation of data, right? So matrices has a fast use in your even coding. So a lot of coding based, a lot of apps, and how even laptop is designed is based on linear algebra. So a lot of concepts from matrices is involved while we code on these languages. And now we'll try to understand first why this is so useful. So I'm telling you about all of this because this is a very basic representation of data. So what matrices do is they store data, they store information. How do they store information? So we have like table like structure. Okay. So what is a matrix first of all? So matrix, matrix, is just a single matrix, right? And if you are taking the plural of it, so matrices, right? So what is a matrix is generally represented by a capital letter. You can use any letter from A to Z, A, B, C, D, E, F. Generally, we use A, P, Q, A, B, X, Y, these letters, right? So let's say we have a matrix A, right? Now, what does A contain? Next question is this, or how does A look? So A will look like a table which will be bounded by these two square brackets or by this, like this. Both of them are the representation of matrix. Right? And inside this, we will write anything, whatever we want to, either any scalar quantity or any vector quantity. But how do we write it? We will write it in rows and columns. So let's say, for example, I'm writing a matrix 1, 2, 3, 4, 5, 6, 7, 8, X. This is a matrix A. Right? Now let's understand what are these horizontal rows and what are these vertical rows. So I can see these three rows. These are horizontal, right? So we call them row. Now, if I take these three, these are vertical rows or vertical lines. We call them columns. So our whole data, either it's a scalar quantity or it's a complex number or it's a vector quantity, it can be anything. We're not commenting on the type of data. We're not commenting on that. We are saying that you can store any information. So you can take any scalar quantity, you can take any number. Generally, we will see numbers or variables, X, Y, Z, right? But we can also take vectors or complex numbers in higher maths. So a matrix will look like this. There are two important things here. First is rows, which are horizontal lines basically. So there are three rows here. Row 1 contain 1, 2, and 3. Row 2 contain 4, 5, and 6. And row 3 contains 7, 8, and X. Right? And then these three vertical lines, which are known as columns. So column 1 contain 1, 4, 7. Column 2 is 2, 5, 8. And column 3 is 3, 6, X. Is that correct? Do you understand this? If you have any doubt, you can ask. Feel free to ask. Okay, so let's understand this through this only. I mean, let's understand the whole matrix first through this example. Then we'll write all the things. We'll have to write also because there are a lot of things here involved which you'll forget if you won't write. So we will have to write, but we'll write it after some time. Let's just understand the structure of matrix first. So one thing is row and one thing is column. So next thing is we'll tell this how many rows and how many columns are involved in a matrix. So right now we have three matrices, three rows and three columns, right? Now let's write another matrix D, which is 1, X, A, B, 10, minus 40. Can you tell me how many rows are there in this matrix?
2.
How are we defining rows? Okay, tell me first row. What are the elements of
Sorry,
first row?
3.
3 rows. Yes. So what are the elements of first row? Elements
1
now
and X.
and row 2. Row 2 is AB, right? And row 3 is 10 minus 14. Okay, and how many columns? Tarif or Mamti? Anyone?
2, sir.
2. And column 1 contains?
1, 8, 10.
Right. Okay. So let's understand two more things. First of all, we'll call these things, we'll call these entries, which we are writing 1 x a b 10 minus 14. We'll call these entries as elements. Okay. So these are the elements of this matrix. There are 6 elements, right? And there are 3 rows and 2 columns. So we will have to write order of a matrix here. Order. Now, how are we defining this order? This order is row into columns. Number of rows into number of columns. You don't have to multiply this. No, you have to write it like this: row, whatever the number of rows, and whatever the number of columns into and a multiplication between them. So for example, here, if I write the order of this B, this will be 3 rows. So 3 into 2 columns. So I'll write the order of any matrix such that number of rows into number of columns. And these will be elements. So I can easily decide how many elements a matrix contains. No? See, this matrix contains 6 elements. But I can easily see that using order 3 into 2. Number of rows into number of columns will be total number of elements of the matrix. For example, the order of this matrix will be 3 cross 3. I'll read it like this: 3 cross 3. So as soon as I say a matrix has order 3 cross 3, you'll understand that it has 3 rows and 3 columns. So there are total 9 elements. There must be 9 elements in this matrix. Right. Okay, now let's talk about the shapes of these matrices. These are the things which you'll have to write, but these are very easy to understand if you understand them. So if we talk about this A matrix, right? So this A matrix has length 3. We can say 3 units in terms of like 3 entries. And same, if we talk about the breadth of it, width of it, that is also 3 units. So it looks like a square, right? If you take the shape of this whole matrix, it looks like a square, right? So we can call it as a square matrix. Now the question is, when will a matrix look like square? Are there any more cases? When will a matrix look square? When the number of entries horizontally are equal to number of entries vertically. No? In all such cases, the matrix will look like a square. Am I correct, guys? Did you understand this?
Yes, sir, I understand.
Just a minute. Hello, Fahad. Am I audible?
Yes,
क्या हाल है?
fine. I'm fine.
And how is the exam?
It went well.
So we are starting with the first chapter, metrics. I have given a short introduction only. So have you started with your 12th classes?
Yes, we have started with inverse trigonometric functions. It's good.
Okay. So we have started with matrices and determinants. These are the first 2 chapters of algebra. So we are starting with algebra first, then we'll go to relations and function, then we'll go to ITF, and then we'll move on to calculus. We'll move it. I mean, we'll move like that. Okay, so matrices, we are trying to understand what are matrices. Matrices are like basically matrices are representation of a data. So matrices is something which we use to store a data. So I'm giving you a simple example first. So this is a matrix A, this is a matrix B. I have written, so matrix is basically like a table which will contain some data. The data points can be scalar, vector, complex, real, can be anything, right? So we can store any information, we can store any data in these tables. So all the matrices are table-like structure, which are basically representing some of the data, or which are basically storing some of the data, right? And there are a lot of use of matrices in your Excel sheet and machine learning and then coding. So matrices is a very important topic. It's a very hot topic from linear algebra. So we are trying to understand this. Now we have to understand two things, first of all, about a matrix. There are two things. For one is horizontal lines. For example, all the blue colored lines. So first horizontal line is 1, 2, 3 in this matrix A. So every matrix will be named with some capital letter. So for example, I have named this with A. So this is A matrix, which contain 9 data points and basically 3 rows and 3 columns. Columns are these vertical lines 1, 4, 7, 2, 5, 8, 3, 6, X. So 1, 4, 7 is column 1, 2, 5, 8 is column 2. All the vertical lines are known as columns. All the horizontal lines are known as rows. So we should understand that a matrix contains some number of rows and some number of columns. And whatever these number of rows into number of columns is, that will be known as order. So order of this matrix A is 3 cross 3. 3 cross 3, why? So first 3 is telling you number of rows. Second is telling you number of columns. So I've written this a similar, another matrix B, which contain 3 rows, 3 horizontal lines and 2 vertical lines. So 3 rows and 2 columns, hence the order is 3 cross 2. So a matrix will contain some number of rows and some number of columns. We will always write the order of the matrix, like number of rows into number of columns. And all the data points or all the entries of this matrix will be known as elements of the matrix. Right? This we have gone through. And now we are trying to understand the shapes of different matrices. So we have these two matrices here. First matrix is A, which has an order 3 cross 3. And second matrix is B, which has an order 3 cross 2. Now the first matrix looks like a square. How? Because the length is 3 units. So let's take length as the number of data points or data entries. Then the length will be 1, 2, 3. So 3 units. And height also 3 units, 1, 4, 7. So this matrix or this table looks like a square table because it has same length and width. While the matrix B has height 3, but width 2. Right? So this matrix looks like a rectangular table. And same are the name of matrices. So first one is a square matrix. And second one is a rectangular matrix. Square matrix, when number of columns and number of rows are same. So a matrix is known as a square matrix. A matrix is known as a square matrix, right? If the number of rows and number of columns are equal. While a matrix is known as rectangular matrix if number of rows and number of columns are not equal. Now, if a matrix is rectangular, there are again two categories. Either the length can be more. In this example, height is more and width is small, right? So this is more vertical. But it could have been this as well. like this. 1, x, 9, 5, 7, 10, right? And in this case, see, now the number of rows are 2 and number of columns are 3. So this has an order 2 cross 3. Right? Now 2 cross 3 and 3 cross 2. So this is a vertical matrix. And this is horizontal matrix. But both are rectangular. Right? So this is how we can define some of the matrices. Right? Now, if we talk about what are the matrices that are important to us, all the square matrices are very important to us. We have a lot of phenomena, lot of concepts involved for these square matrices. We'll study about them, but first let's understand the types of matrices and the basic terminologies of matrices. So all the square matrices are important. And now, whatever we talk about, we'll mostly talk about square matrices. So there are some basic questions on these matrices which are not square, but other than that, all the important concepts or all the phenomena which you are doing, which you will be doing in this chapter, will be based on square matrices. Some basic calculation type questions or some very basic questions are based on rectangular matrices. So these are the type of matrices. Now let's again once understand how can we write a matrix easily, or what is the basic general form of a matrix. So a matrix will be written like this. Let's say I have this matrix A. I will write it as Aij m cross n. Now understand first, what is this saying? So if I write this A is equals to Aij m cross n, then it means this is a matrix A whose element of the matrix, whose element is known as Aij. So this Aij is the element which belong to ith row and jth column. Ith row and jth column, it basically means every element can be written as Aij, where Aij, I and j are the representation of the row and column of that entry. For example, this one, this belongs to first row and first column. First row and first column means if I have to write it in the form of Aij, I will write it as A11 because first row, first column. Now this 2. So this is first row again, first row but second column. First row but second column. So this will be written as A12, A13. Can you tell me this 4? How do we write this? In the form of Aij. Just tell me what is the value of I and j here. I is the number of row of this element.
A21.
A21, correct. What about 5? 5 and 6.
A22.
A22 and
A23.
A23. Similarly, A31, A32, A33. Right? So these are the elements basically. This will have some value, but for the base, representation, we have written it like Aij, which basically means we are talking about the element which belongs to ith row and jth column. So we are talking about the element which belongs to this particular row and this particular column. So that is how we can design this matrix A. And M cross N is basically telling us the order that it contains, the matrix A contains M number of rows and N number of columns, right? Okay, and let's understand one more thing as well. So I can also design a matrix, right? If I give you some condition, or if I give you some function, some equation, you can easily design a matrix. So for example, let me show you first of all what can we do. So we have this matrix. So let's say we are given form A if, so we have to form a matrix A if A is equals to, so it's been given that A is equals to Aij, okay, 2 cross 3 means that we have 2 number of rows and 3 number of columns, so there are total 6 elements, right? And the structure will be such. We just don't know these entries, right? For now, we think this is A11, right? A11, this is A12, this is A13. So we can design like that. But I'm also giving you the condition for Aij. I'm telling you the value of Aij. So what is Aij? Aij is mod of I minus j. Mod of I minus j. Now let's understand what are we trying to say here. So first of all, if I'm given this question, Aij, A is equals to Aij 2 cross 3. So first I'll write A. I'll say that A should be A11, right? First row, first column, first row, second column, first row, third column, then second row, first column, second row, second column, second row, third column. This is a matrix 2 cross 3. So this is the original matrix. But we know the value of A11. How? Because we can calculate A11 from this formula. We have been given how to calculate Aij. So in this case, I'll first write my matrix like this, and then I'll try to find out these A11, A12, A13. So for example, A11 here. So for A11, I is 1, J is 1. This will be 0, right? Similarly, A12 can be calculated in the similar way. 1 minus 2. 1 minus 2 will be minus 1. Now we are taking mod of minus 1. So it's 1. A13, 2. What are we actually calculating? We are calculating the distance between I and J. This is the distance. This is the representation of a distance. If you want to find out the distance, you will calculate like this. Aij, mod of I minus J. So A21 will be 1, A22 will be 0, A23 will be again 1, because 2 has same distance from 3 and 1. So A21 as well as A23 both are same and are equal to 1. So our matrix A, now we got the matrix. Our matrix A will be this 0, 1, 2, 1, 0, 1. So that is how we can design a matrix if we are given some equation or some formulation for that. But the basic use of matrix is to store information. To store information and to extract information from it. You can easily apply a lot of it, different formulae. Can I remove this? If you're writing, just raise your hand.
Sir, can you explain the example once more?
Yes, Tarif. So what are we doing here is we are actually designing the matrix. So we can name every element of the matrix in the form of Aij. This is a basic representation of the elements of the matrix. So for example, the first element, the very first element means the element of first row and first column. That can be termed as A11. Then similarly, A12, A13, A21, A22, A23. Did you get this portion that how to write any matrix in the form of Aij?
Yes, sir, that I understood.
Okay. So if we can write any matrix in the form of Aij, and we are given how to calculate Aij, then we can form that matrix. Now how? First we have written this, then now we have given Aij is equals to mod of I minus j. So mod, what does mod do? You know what does mod do, right? Mod makes anything positive, right? Now we have to calculate Aij is equals to mod of I minus j. So if I'm calculating A11, that is the first, this element. So A11 will be 1 minus 1, which is 0. A12 will be mod of 1 minus 2. 1 minus 2 would be minus 1. And mod of minus 1 would be 1. Did you get this? Correct?
Yes, sir.
Similarly, we have calculated every one of them. So for example, A13. How did we calculate A13? A13 will be mod of 1 minus 3, which will be mod of minus 2. The answer will be 2. So you can calculate any one of them using this formula. And then when we've calculated all of them, we have placed the value. So I've started from here till this point. And similarly, we can design. I'll change this formulation only or order. So the order and formulation will be changed and you have to design a matrix. Can you do that? Now, क्यों तारीफ हो जाएगा?
Yes, sir, clear.
ठीक है, चलो फिर करो सभी लोग. Humamuddin, do you understand Hindi?
Yes, I understood.
ठीक है. No, my question was, do you understand Hindi?
Yes, I understood Hindi also.
ठीक है, ठीक है, ठीक है. So you have to calculate this another, you have to form this matrix Aij, which is mod over I square minus j square. Guys, did you solve this? Okay, this is I square minus j square, right? Just have to put those values I and j. Here I'm corrected. So the matrix should be 0, 3, 8, first row, and second row would be 3, 0, 5. And this has to be the matrix. Okay, so let's start with some basic definition first. And let me first check what we have. Okay, till then we can solve another question. Form this matrix A, or rather form B, whose element is Bij, and this is 3 cross 4, where Bij is equals to I plus j divided by I minus j, when I is not equals to j. And when I is equals to j, then this Bij is 1. Form this matrix.
So,
Yes,
I did not copy the question.
just this is the question. We have to form this matrix. Bij is given as I plus j upon I minus j when I not equal to j. And when I is equals to j. So what does we mean by I is equals to j? I mean, how do you interpret this? I is representing the number of columns to which the element belong. And j also represent the number of, I represent the number of row, and j the number of column to which that element is belong. Now, when I is equals to j, it means that the element is belonging to the same row and same column, which means either it can belong to first row, first column, or it can belong to second row, second column, or it can belong to third row, third column, right? Fourth row, fourth column will not be there because the order is 3 cross 4. So there are maximum 3 number of rows only. And when I is not equal to j, then you have to use the formula to calculate bij. So whoever is done, just raise your hand. You don't have to write the answer. Chalo fatafat karo. This is easy. And all of these are easy. You just have to calculate. Calculation. Yes, anybody's done. So it will be A11. It will be 1. I is equals to j, then it's 1. Sorry, A not A11, B11. This time we are representing the element as Bij. What will be B12? Now B12, when we calculate B12, I is not equal to j. See, I is 1 here, j is 2. So I is not equal to j. Hence, we can use this formula to calculate B12. What's the value of B12? Did anyone calculate? Fahad, what's the value of B12?
Is it -3?
-3. And B13? Is this? Did you understand how to form this? Please feel free to ask. If you haven't, just raise your hand. I'll explain it again. It's okay, you all are safe. Yeah, understood that. It's good. But this is an easy task. No, nothing to worry about. You just have to think about how to form this matrix. First of all, understand the order. So there should be 12 elements in this matrix, B 3 cross 4. Right? So we will write it as B11, B12, B13, B14, then B21, B22, B23, B24. Similarly, up to B34. Right? And then we'll use this condition to formulate the matrix. Now B11, in case of B11, I and J are equal. We are given two conditions here. If I is not equal to J, then the formula, we have to use the formula. And if I is equals to J, then we have to write the correct answer 1. So while calculating B14, we have to use this formula again because I is not equal to J, right? This should be minus 5, sorry, 5 by minus 3. So minus 5 by 3. Now B21 would be 3. B22, 1 again, because I is equals to J. B23 would be minus 5. B24 would be minus 3. B31 would be 2. B32 would be 5. B33 be 1. Now B34 would be 7 minus. So that is how we can formulate this. Okay, let's understand. No, I mean, let's start with some of the basic definitions. So first up is metrics. Can I remove this? So first up is matrix. What is a matrix? A rectangular array, in fact, an ordered rectangular array. You know, right? Square is also a rectangle. Square as well. So an ordered, which means that order matrix, which row and which column you're talking about, that matters to us because that gives the information, that gives a data point, right? So order is important. An ordered rectangular array, right? Of array means representation. So this is an ordered rectangular representation of some numbers or functions or vectors or complex numbers, can be anything. What are the important things? First is order. Tells the number of rows into number of columns. That is how you write the order. All the entries or data points, all the entries of matrix are known as elements of matrix. So you can call all of these entries as the elements of matrix. How to write a matrix? So this is a basic example. A is equals to Aij m cross n. M tells you number of, so use hashtag for number of rows, number of columns. This tells you the element of the matrix. Which element? Which belongs to ith row and jth column. Right? So you can write any matrix like this. And this is an example of the same. This is a complex number, I. This is a matrix of order 2 cross 3. Also, the total number of elements of a matrix will be number of rows into number of columns. Okay, so a basic question from this will be, if I tell you the number of elements, can you tell me the possible orders of the matrix? This is a question. A matrix has 12 elements. A matrix has 12 elements. What are the possible orders? Of the matrix. Can you tell me this?
2 cross 6.
2 cross 6, yes. It can be done. But is this the only one?
1
Uh,
4 cross 3.
4 cross 3?
1 cross 2.
12
1
cross 1.
cross 12? 12 cross 1? All of the, if you found even a single multiplication form, just first numbers. So it can either be written as 1 into 12, or 2 into 6, or 3 into 4. And similarly, just for a matrix, for this kind of matrix. Okay, can the, one more question, can the total number of a matrix be odd? Total number of elements of the matrix, can they be odd number of elements? Like in this case, the matrix has 12 elements, so it's even number of elements, right? Can they be odd? That is my question.
Yes.
And when?
1 cross 11.
1 cross 11, 3 cross 3. There are so many cases. Guys, just a minute. Yes. So, yeah, total number of elements can be odd or even, and we can certainly find the possible orders of the matrix, right? If we know the number of elements of that matrix. okay, the next question is, if I give you an order, right? Oh, sorry, if I give you the number of elements, can you tell me the order always? Like, you can tell me the possible orders, but can you exactly find out the order in any case? So, okay, let's say the total number of elements are 13. The total number of elements are 13. Now, can you tell me the order of this matrix?
1 into 1 cross 13.
But we cannot definitely tell the order. I mean, the size of the matrix. I mean, it can either be 1 cross 13 or 13 cross 1. So there will never be this
13 cross
case.
0.
If 13 cross 0, then 13 cross 0 means 0 column. So basically no entry. It doesn't matter in that case how many rows you have. So minimum there should be 1 row and 1 column. We can't have 0 rows or 0 columns if we have to write the matrix. In all such cases in which the number of rows or number of columns is 0, the matrix will not exist. So 13 cross 1 or 1 cross 13. There are two possible orders. So what I'm saying is, you cannot be certain about the order. If until unless you are given some situation like if it's given that the number of rows are more than number of columns, right? The number of rows are more than number of columns, and the total number of elements are 13. Now we can guess the exact order or exact size of the matrix, the 13 cross 1, because the number of rows are more than number of columns. Right? So until unless we are not given some specific situation, we cannot definitely guess one possible, one order. There will be minimum 2 possible orders. Just like this case, 1 cross 13 and 13 cross 1. Right? Okay. You can complete first exercise by the way. Just have to write some definitions, but the basic definitions, nothing fancy. You already know these things. If you just go through with this with yourself, you'll understand this. Can I remove this? Okay. So what we are going through is types of matrices now. And these are very basic types. So first is, we call it as a column matrix. Now, what is a column matrix? Which only contain one column. That is a column matrix. So contains one column only. Wait just a moment. The column matrix will always contain only one column, right? That is the definition of column matrix. And similarly, row matrix, which contain only one. So I'm giving you an example how column matrix will look like. So column matrix will always be n cross 1. There can be n number of rows, but there will always be one column only. So rows can be anything. For example, here I'm writing 3 cross 1. It means there is one column and 3 entries in it. Similarly, row matrix contains only one row. For example, 1 x 3 4, 1 cross 4. So its order is 1 cross m or 1 cross n, and this order is m cross 1. M number of rows, 1 column. Row matrix is 1 row, n number of columns. Columns can be anything. I mean, any number of columns are possible, but there is only one row possible. Then row matrix, similarly column matrix. Now square matrix, third is square matrix. Now what is square matrix? If number of rows is equals to number of columns. So you can more if you want to write this mathematically, you can write it like this. So a matrix A is equals to Aij m cross n will be called square if m is equals to n. And 3 cross 3. For example, 1, 4, which is, let's say, x1, 2, 2, 3, 4, 0, minus 1, minus 2. So we can see that this is a matrix, square matrix of order 2. So as soon as I say square matrix, I don't need to say both of them, rows and columns. Square matrix of order 2. Square matrix of order 3. Now one more important thing. When I see square, I can also spot the diagonal. Right? Now talk about this matrix B. There are two diagonals here. First diagonal contain x3 and minus 2. x3 and minus 2. This is the first diagonal. And second diagonal is 2, 3, 0. 2, 3, 0. Right? But there is something special about the first diagonal. Let's talk about x. X is the element which belongs to first row and first column. So I can write it as b11, small b11. अगर जनरल फॉर्म में मैं इसको लिखता तो मैं इसको b11 लिखता. Now this is b12, b13, right? This is b13. This is b22, second row, second column. This is b23, sorry, 33. तो ये जो first diagonal है, which is x3 and minus 2, this contains all the elements which belong to same row and same column. So this x is first row, first column, this 3 is second row, second column, and this minus 2 is third row, third column. Because of this property, that when we write all of these elements, I and j both are same. Because of this property, they are known as diagonal elements. Diagonal elements. So all the elements of type A11, A22, A33, A44, A55 are known as diagonal elements, and diagonal elements only exist in case of square matrix. Don't take a rectangular matrix and say that A11, we can write A11 here, so A11 is a diagonal element. No. Diagonal element only exists in case of square, because there is no diagonal actually in rectangle. I mean, there is a diagonal in rectangle, but if you talk about a matrix, you won't form a diagonal here. There is no diagonal. I said this diagonal because there is a diagonal, and that diagonal exactly falls on x3 and minus 2. Now, if I draw a diagonal here, there is no diagonal. Why? Because there are no certain elements on that diagonal. So diagonal, the concept of diagonal elements only exist in case of square matrix, and all of these elements are known as diagonal elements. So this is principal diagonal, x3 and minus 2, and 2, 3, and 0. The second diagonal is known as secondary diagonal. We don't have to deal with secondary diagonal. The important thing is principal diagonal. You will forget that these two are even known as principal diagonal and secondary diagonal. You don't have to worry about that, but if you can remember, just know that. And we have to think about these elements all the time. We'll be finding them out. Okay, these diagonal elements. So in case of Aij, if I is equals to j, is known as diagonal elements. Now, what are the diagonal elements? A11, for example, A1, A22, A33, etc. So यहाँ पे diagonal elements हुए. X3 minus 2. And fourth is rectangular matrix. Please complete fourth as well.